Imagine, if you can a time before a time, a moment when everything we know, every star, every galaxy, every atom, was compressed into a space smaller than a grain of sand. This was the beginning.
8 billion years ago, from an infinitely dense and hot singularity, the universe was born in an event we call the Big Bang. In the first fleeting fraction of a second, an incredible force, cosmic inflation, propelled the nascent universe outward at a speed we can barely comprehend. As it expanded, it cooled, energy transformed into the fundamental building blocks, tiny quarks and electrons soon. These quarks combine, forming the very first proton and neutron. The stage was set for creation.
Just minutes after its birth, the universe continued its grand performance. The extreme temperatures and pressures allowed for the next crucial step, nuclear fusion. Protons and neutrons, drawn together by powerful forces, fused to create the first atomic nuclei, hydrogen and helium. The universe's primordial ingredients were forgotten.
Hundreds of thousands of years, the universe remained a dense, opaque fog. Light could not travel freely. But then, about 380,000 years after the Big Bang, a pivotal moment arrived. The universe could enough of electrons to finally join those nuclei, forming neutron atoms. This era is known as recombination.
The cosmic veil lifted. Light was free to travel. This ancient light, stretched and cooled over billions of years, is still detectable today as the cosmic microwave background radiation, an echo of the universe's infancy.
With transparency came darkness, but not for long. Across the vast, newly formed universe, tiny irregularities in the distribution of matter began to exert their influence. Gravity, the great sculpture of the cosmos, pulled these denser regions together.
About 100 million years, the first stars ignited. Immense, short-lived giants known as population 3 stars. These weren't just celestial lights. They were cosmic furnaces fusing hydrogen and helium into heavier elements like carbon and oxygen within their fiery cores. As more stars were born, gravity continued its work, drawing them together into magnificent clusters. The earliest galaxies began to take shape, islands of light in the vast cosmic ocean.
But even stars, these magnificent creators, have a lifespan. To most massive stars, having lived fast and burned brightly, met their end in spectacular fashion, a supernova explosion. These cataclysms were not just destructive, they were essential for life. Supernovae are the universe's ultimate recycling program. Their immense explosions scattered the heavy elements forged within their cores, everything from iron to gold, across vast reaches of space. This enriched cosmic dust and gas became the building blocks for the next generation. From these fertile interstellar clouds, new stars were born, like our very own Sun, belonging to a class we call second-generation stars, brimming with the complex elements needed for planets and for life.
Go.
And so truly, 4.6 billion years ago, our own cosmic story began. In a vast, good cloud of dust and gas, a nebula, enriched by the remnants of ancient stars. Gravity once again took hold, perhaps triggered by the shockwave of a nearby supernova. This giant molecule cloud began to collapse inward.
As it collapsed, it flattened and spun, forming a swirling protoplanetary disk. At its heart, most of the material accumulated, becoming a dense, hot protostar, and then, through immense pressures and ignition, our sun blazed to life, a new star in a new system. Out in the disk, tiny dust grains began to collide and stick together gradually, forming larger and larger clumps called planetesimals. These planetesimals, through a process called accretion, continued to collide and merge, growing into the first protoplanets.
Protoplanet, orbiting within the sun's habitable zone. The perfect distance for liquid water grew into what would become our home. Early Earth, just after its formation, was a hellish molten world consistently bombarded by leftover debris.
4.5 billion years ago, a cataclysmic event shaped our destiny. A Mars-sized body, theorized to be called Theia, slammed into the young Earth. The impact was unfathomable, pulverizing both bodies and launching an enormous amount of debris into orbit. Over time, the debris coalesced, forming our constant companion in the night sky, the Moon.
Slowly, gradually, Earth began to cool. A solid crust started to form on its surface. From deep within, refutless volcanic activity began. These early volcanoes spewed vast amounts of water vapor, carbon dioxide, and other gases into the nascent atmosphere, setting the stage for the next crucial chapter. Earth continued to cool. A monumental transformation occurred. The vast amounts of water vapor in the atmosphere condensed, falling as torrential rain for millions of years. This deluge filled the planet's basins, giving birth to the first oceans. Below these new waters, Earth crust stabilized and the slow dance of plate tectonics began, gradually forming the first rudimentary continents.
Environment and the rich soup of carbon compounds, fueled by energy from lightning, volcanic heat, and UV radiation. A new kind of chemistry began. In the oceans, perhaps near hydrothermal vents, spewing mineral-rich fluids, simple organic molecules like amino acids and nucleotides started to form. This was the cradle of life. These molecules, through process still being unraveled, began to self-assemble, to replicate, to evolve, and form, and from the incredible, improbable leap, the first living system emerged from
single point of infinite density, through cosmic bullet of stars and galaxy, through planetary collisions and volcanic outpourings, a blue marble teeming with life arose. Our story is truly the story of the universe.